Everyone. My name is Selva and I am with Guru. We are going to talk about DiabTick. Diabetic is inspired from a recent event where we attended, where we saw all the type 1 diabetes children aged from 1 to 10 to 15. We saw the pain these kids were going through, um, you know, to inject insulin every meal, before every meal they take. It was a quite painful situation for them. Plus, they have to have a notebook to track, the insulin they are injecting and the amount of food, amount of carbohydrates they are consuming. It is a very tedious process for the parents, especially for those younger kids, because they usually eat very specific food, and it's extremely difficult for parents to track the carbohydrates and then inject the insulin to them. So we wanted to develop app which will solve this problem for them. Take a picture of the food plate or bowl and send it to our AI enabled app that is deployed in Airia, that will instantly give the amount of insulin they have to inject before taking that meal. So it is that easy. So we would love to extend this feature by adding, collecting more information about the individual user, uh, by giving information like their age, their eating pattern, their insulin injection units, number of units, and then their food habits and stuff. That will give more accurate insulin units to be taken, as well as we can provide an analytics of how much it is done, whether it is reducing over the period of time, weekly basis, daily basis, monthly basis, yearly basis. We can provide the complete insight for an individual, so he or she can actually do better on their insulin intake. So that's the whole idea about this product. I'll hand over to Guru for a demo, so you get to know better about DiabTick.
Thank you for handing over the data. So basically, you can visualize from my screen, right? So on the left side, we have the Airia platform, which makes it pretty much simple for us to understand as well as develop an AI agent on their platform to help support this great cause. So what we are using here is basically the input would be the users sending us the image with some contextual data, let's say about the age, or maybe something special they want to inform, which would affect the calculation for the insulin dosage. So that would be the input, and that would go through a data source pipeline doing a RAG, which would basically trickle down from FDA approved calculation methodologies and international diabetic organization based research data for like food based consumption and insulation levels. And it will go through all those documents and with the context and try to extrapolate the calculation for the insulin, and then provide all those contexts to the AI model, in our case, which is the GPT-4 Turbo. And that will basically take all this data along with the image to recognize the meal, and then give us the total nutritional components and the segregation in the sense of how many carbs, sugar, fiber, and all the male nutrients, and which would impact the insulin dosage. And it will give a breakdown of how it is going to calculate the insulin dosage, as well as then provide the actual dosage recommendation. So for example, I would show you, we are using the Aria chat application, which is available on iOS at the moment. And we just uploaded an image of a pizza which we ate earlier. So you can see from there that it is trying to identify the meal, which says, and you can see the portion size also, it's trying to identify according to which it would calculate the nutrition. So it is able to calculate approximately how many calories, carbs, protein, fat, fiber, everything just from an OCR pipeline. And then it is skipping to the phase where it's trying to calculate our insulin dosage. So it's going by different phases where it would see the carbohydrate based calculation, then it take in the glycemic index onsets and the macronutrient impacts and the meal complexity, and adjust and give you the actual units you need to basically dose before you eat the food. So that's after that you can see the recommendations and also where it's getting all these calculations from, just so we can advise that this has to be used in coordination to your doctor's recommendation and prescriptions. So this is what we are able to achieve at the moment using Airia with a very quick and very reliable and easy solution. So yeah, I pass it back to you, Salva sir, for
Yeah.
explaining.
Thanks, Guru. So the next step, what we are looking at is we are exposing the model which we built in Airia via APIs through the token. So we have the API keys from Airia, and we can access these models using the API. So we are building an app, both iOS and Android, which will have a simple, chat-like interface, like an AI app we can call, and that will call the API from Airia, and the response will be coming back to the UI. So this will have added benefits of storing the users' information, their history, and that will enable us to show the analytics. So that's the next step. And the third step we have is we have connection with few doctors in Singapore who are really looking forward to use this app, and they want to recommend this app to their patients. So it's quite easy for them to consume, and as the AI model becomes smarter and smarter, they will have more smarter product to make this decision at much accurate stage. So that's the vision and mission for DiabTick. Thank you very much for Airia to give us this opportunity through this hackathon. We are happy to collaborate, partner with you guys in future. Thank you.